All right. Greetings, everyone. Thank you for joining our webinar. We are, this is our third one. We're going to do these in a series now. And tonight we have a special guest. We have Andrew Dennis from Gigacrete. He's the founder and CEO of a remarkable building system that we've been using for, gosh, about over 15 years, I think now. I'm not sure, but we'll get into
Yeah.
that
Yeah,
heavily as we
probably.
go. And we have Bob Niesner, our contractor with Champion Builders, and my partner Karen Airy Lacron, and we will get started. First, before actually I get started, I want to let everybody know if you hit the chat button on your screen, you can chat and ask questions with us. We'll try and answer those as we see them. If not, we'll try and answer them at the end. If we don't get to them, we'll send you an email, or you can email us with your questions. That'd be great. Okay, so who are we? We are Ariel Lacron Architects. We've been in business since 1989. I'm James Lacron, licensed architect in California and in Hawaii, and I'm a native of Pacific Palisades, born and raised.
And I'm Karen Ari Lacron. I'm a licensed architect in California. I'm also a past resident of Pacific Palisades.
Hello, I'm Bob Niesner. I'm president and owner of Champion Builders. I've been working here in Southern California for over 45 years, and I specialize in all types, sizes of residential construction, uh, high end to mid range. And I do hope you pick something up. We're going to bring a lot of very positive things here, and I hope you do pick up a lot of it.
I'm Andrew Dennis. I used to live in Palos Verdes for 22 years, very familiar with LA and California. Later moved to San Diego, where I actually invented the product there. And I was offered a job, most interesting one, to conceive and help design New York, and Las Vegas. I went there for 7 months, 32 years ago. I'm still here. So we now manufacture in Las Vegas. We have a showroom there. All of you that are attending right now are very welcome to come out to the factory. We had 8 people from um, Altadena this morning. In this last week, we probably had 15 to 20 people through. And we've had a few from Palisades, and we're here to help.
Okay, so the agenda tonight, we're going to try to keep it an hour under. I know this is a busy time for everybody at the dinner time. So we're going to actually divide it into 4 different segments. The first being our experience with wildfires. The second is fire smart design techniques. The third is Gigacrete building system. And then the fourth is working with an architect and a builder. So our experience with wildfires, very vast.
Yeah, it goes all the way back to 1978. I was just graduating from Pali High in Pacific Palisades, and the first Palisades fire we thought was a big deal, and it almost burned our house. I lived at the top of El Medio, uh, burned 30 houses, slightly less than this one. Our next experience, we just started our practice. We did a house for some friends in Oakland, and immediately after that, the tunnel fire in Oakland took 32 houses, and we did not lose the house that we designed. We had the T fire in Santa Barbara, and this house that you see was we had designed it a few years before that, and it survived the T fire. Everything else in the neighborhood burned. In 2017, we had the Tubbs fire in Sonoma County in Santa Rosa. And this was kind of the first experience of a wildfire burning into an urban environment. much like you see now in the Palisades in Altadena. With that fire, we did a project with Habitat for Humanity in Santa Rosa to do some ADUs, and we used the Gigacrete system for that project. 2017, the Thomas Fire in Ventura and Santa Barbara took 1,000 houses. We had a house in Montecito that we had designed that survived the Thomas Fire. And then we did a rebuild in Ventura from a house that burned in the Thomas Fire, again using the Gigacrete building system. 2018, the Hill and Woolsey fires simultaneously in Malibu and Thousand Oaks, another 1,600 homes destroyed. We did 3 rebuilds from the Woolsey fire in Malibu, one of them using the Gigacrete system. And then in 2023, we had the Lahaina fire. We've done a lot of work on Maui, nothing in Lahaina per se, but all on West Maui. No one saw this one coming, but again, another urban disaster brought on by a wildfire. There's been an average of 2 fires in the Malibu area every decade since 1929. And anybody who lives there is familiar with this. Malibu burns all the time. And now we've got the Palisades fire and the Eaton fire. So we're talking over 15,000 houses. This is the biggest event in history. And if you look at the homes at risk for wildfire in California, uh, you can see indicated by the red, it's pretty much all of California except for the Central Valley and some in the high desert. So if you think you can move away from just the hills, we've seen it in the urban areas. It's you have to be prepared for wildfire no matter where you are. And looking at a broader map of the United States, it's pretty much the entire western half of the United States. Um, Wildfire is not going away. It's a thing.
And unfortunately, wildfire is a given occurrence, and it will happen again. And we have never lost a home that we designed to wildfire. And if you're going to build in a location where wildfire could happen, you must build fire smart. It is possible to design a home that will resist wildfire and dramatically raise the chances of saving your home.
So what are the components to fire smart design? There's active measures and passive measures, and we'll get into both of those and explain the difference. Passive measures are architecture, the actual design of the building itself, the materials used in the construction of the home, and defensible space. And we'll talk about that. That's kind of the new buzzword out there. So let's talk about architecture first, the actual architectural design. Architectural style can be very important in fire smart design.
This is a house that Jim, Karen, Andrew, and myself built out in Little Holmby. And it was built by Gigacrete all around. It's got a flat roof on top that helps quite a bit in fire safe building. There you see tile floors on all the balconies, metal railing. This house is exceptionally fire resistant. Even the siding is a fire resistant siding. The interior, if you take a look at those windows, they're all metal windows with dual glazed glass, another element of keeping that fire out of the house. Very important element.
This is another house that we did in Montecito. Mediterranean style is very good for fire smart design. This house is actually a stick-built house. It could easily be a Gigacrete house. It would be even better. This house survived the Thomas fire. Stone siding, tile roofs, stucco, all non-combustible materials, very high quality windows.
And some of the designs that we do to keep the fire resistant elements out, or it's French and European with minimal eaves, slate roofing, plaster and stone. There's no gutters at all. Then also the Spanish has minimal eaves, plaster and tile roofing.
These are some projects
As,
that Bob has
as you notice, in these houses, excuse me, Jim, as you notice, these houses have varying styles, designs, again, stone, concrete roof, uh, metal framed windows, double glazed glass. And the thing I want you all to see is that we can build any style home you want, all fire safe.
We could do these are houses that we've all three of these are Gigacrete, and we've done these over the years. So Gigacrete would be any style and any size. So the materials are the most important part besides the architecture, probably more important. And now I'm going to bring in Andrew, and he's going to tell you all about Gigacrete.
Okay, we're actually a steel frame building system, but we build with the insulation first. And this is one to get your head around without actually seeing it. You'll see slides later. We basically take a giant piece of styrofoam, a big block, 3 feet by 4 feet by 20 feet tall, slice it into panels that are 6 inches thick, and then cut into that with hot wire technology where the steel stud slides in. So that means it's all been cut on a computer. It means you don't need a tape measure, you don't need a square, um, which helps with rapid assembly. So because our foam is 6 inches thick, we fit very well into this Department of Energy Hearst index. You can see the numbers here. 0 to 150 new homes that meet new code come in at 100. We come in at 2. So what that means is we've reduced heating, ventilating, and cooling, HVAC equipment, hugely. We've downsized everything. Solar panels, instead of 100, might be 20. So there's big savings there. Speed to build is really where we excel. This is one of the fire tests we did back in 2007 and 8, and we exceeded the 15-minute fire test. And this was a bit of a shock for us because this is a drywall replacement test. And I asked them, I wanted to do a 1 hour fire test, and they said there isn't one, not over foam. It's a 15-minute test. And I said, are you telling me that gypsum board fails? And they said, yes, it fails in 16 minutes. That's why the test was made for 15 minutes. This is not right. So at 22 minutes, I told them, keep it going. I'll pay you $100 a minute past the 15-minute mark. We get to 22 minutes, and I was forced to stop it. And I found out later, being a disruptor, we were told that there's a disruption right there. That's glowing white hot on my hand.
Yeah,
Um,
that blew me away. I've seen this slide. I never knew you were actually holding it with your hand.
yeah, it wasn't someone else with that tolerated pain. It was
Your
warm,
hand
but it
didn't
wasn't
even
hot.
your hand didn't even get hot, you said, right?
No, it was warm, but not hot. So basically, we've taken on the lumber industry, the drywall industry, and the Portland cement industry. We don't use any of those ingredients at all. This is a test in-house where we put a 1700-degree flame directly on stucco max over a foam panel, proving that even at 3/16 thick, we can stop the heat going through. This went on, and we're simulating this ASTM E119, which is a big deal. And this is the one that building and safety need to see. When you say you've got a non-combustible material, that's the one they're looking for. So this is our what we now call our Inferno series that we kept going for actually 4 hours. We're registering 3 hours right here. Nobody's done this, and we're capable of doing this without adding a huge amount of cost to the house. So according to Google, these forest fires and the wildfires that rage through the communities are about 1400 to 1500 degrees. So that's always the target. Any test we do, we start at this and go up to 1700 F. Next slide, Jim. This is the sole survivor of the Wolsey Canyon fire. There's 115 wooden houses down below this that disappeared. The homeowner tried to leave. The road was blocked. He came back to his home, not knowing what was going to happen. He did try and hose the hillside down, thinking the fire would go around him, which it did. It's my understanding it burned the hose, so the hose was no longer working. And he told me that the embers burning through his shirt. It was something he hadn't accounted for. He went upstairs, took a photograph through the window. That's one of the shots of the fire surrounding the house. We had no damage. We are Miami-Dade approved as the only flood resistant, hurricane resistant, F4 tornado resistant. We're actually 245 mile an hour approved, and that was the limit of their test equipment. We know we've been through 268 in the Caribbean. Next slide, we're showing here our coatings that are compared with Portland cement-based products next to it. So we've got basically acids, salt, phosphates, sulfuric and phosphoric acid, very corrosive to Portland cement, not ours. This is an ongoing water column test. This is 5 feet of water. It's bonded to Stuccomax on 1 inch of foam. The photograph at the bottom right, we see the square. That's where we cut the foam away, and you're looking at the backside of 3/16 Stuccomax that has now been under pressure for 13 years. It's actually 13 and a half years almost. It was March 28th, 2012. So this is our waterproof exterior finish and our waterproof roof finish. This is actually the Miami-Dade testing that we went through. Compression, tension, racking, rack and shear, load, missile impact test. I'll explain that one in a second. And what's called a cyclic load, which is really a seismic event. It's basically a panel hydraulically pushed and pulled at the same time. Like the large missile impact test, when we sent the materials out to be approved and then tested, you have to make everything in front of the lab so they can see that you're not cheating. They know exactly how you're putting it all together. And the guy called me, our main testing guy from the company went out there, spent the week there. And the lab called and they said, no way you're going to pass the first test. Your coating's too thin. And I said, okay, which one of these tests is the first test? And he said, it's called the missile impact test. Do you want to do the light version or the heavy version? I said, well, the heavy version, of course. He said, no way. That it's a 2x4 shot out of an air cannon. It will go through a hollow cement block and kill you on the other side. And we bounced off 12 times. So I asked him, I said, did it crack? He said, yeah. I said, did it come off? He said, no. I said, did it crack on the back side of the wall, on the interior Plastamax side? He said, no. I said, okay, next time we do this, can I stand behind it when you do it? And he said, why do you want to do that? I said, I want to step out and say I stand behind my product. So they wouldn't allow me to do it. Neither would our insurance company. Anyway, this is a list of all the other ICC and ASTM. That's an international building, including Green Guard at the bottom. We won awards in 2007 from Popular Mechanics, Engineering News Record, and Building News magazines as the greenest new product in America by far. And then obviously we had to go through all of these individual tests. And we use a company called Intertech to do that.
Yeah, just to interject a little bit, you when you say new, you're not new anymore. We've been using you for almost 15 years, and I get people all the time saying, "Oh, I don't want to use a new product." I mean, we've been using you for a long time. So,
2005, we formed the company in Las Vegas.
yeah,
2007, we went through code approvals and put brand new product in the market. In 2008, just in time for the recession.
yeah.
So the timing didn't work really well.
Well,
So
I think we knew that there is a better way of building, and Jim and I being architects and knowing there's just one way with stick building, that's what drew us to Gigacrete and finding out more. And it's been over 13, 14 years. And where even if there hasn't been a fire, we've used it for what Andrew was talking about for wind and different elements that we have all
We
over the
yeah,
country.
we've used your I'd have to tally up how many projects we've done with it. I mean, we still do conventional framing and we do, all of that, but we use this whenever we can. And this is one we did in the Caribbean.
this is our most famous Caribbean home. It's been through multiple Category 5s. And then during Hurricane Dorian, it was flooded 5 feet deep with seawater. They lost all the furniture. We had no damage to the house. It's designed to do that. And that was one of the tests earlier, the cylinders with salt water and all of that. That this is the final result that we proved it.
Yeah. Now, funny story with that, the house was we had designed to be on stilts so you could park underneath it because of the floodplain, concrete stilts, but to save money, they decided to put it down on the ground and then they got flooded. So
It's actually on the beach. It
on
was
the
very close to the
beach.
water. Yeah. This is on St. Thomas. The photograph at the bottom shows two buildings. We're in the bottom right. The one on the left, if you go vertically above that, the wood framed house completely shattered. Um, and in the next slide coming up, Jim, click to the next one. That's Home Depot in the back, and that's a concrete wall panel blown in. And even the solar panels were still on our house. They're connected through the roof into 2 by 12 steel roof joists inside.
What
The only damage to the whole house was the gutter, which we didn't even supply.
what was the wind speed on that? You said there was a wind speed indicator that then blew off the top of the building.
That's actually another house
Oh,
that's
okay.
right on top of the hill. And it snapped off the anemometer, the wind speed indicator, at 268 miles an hour. And we had no damage to the house. FEMA have been to see these at least 3 times that I'm aware of.
Yeah.
Wow.
Um, Having lived in Southern California as an architect and industrial designer, I was very familiar with earthquakes. I actually didn't design any homes when I lived in California. I was doing everything but that. So we are seismic zone 4 tested, well proven. We've got homes in Haiti and Guam that have gone through 7.3 earthquakes with no damage, and that's a pretty earthquake to go through. In fact, the one in Haiti, that was the first thing we ever shipped. That has now become the hurricane shelter and
Right.
the earthquake shelter for the village.
Right.
This
Exactly.
is in Oxnard, California. It's first of the food services building we've done. We built this inside the factory with 8 California contractors and 4 of our people, so 12 altogether in 2.5 hours. All the walls were up. The builder, the contractor, basically learned it in half a day. We packed it up and shipped it. It arrived there on Monday and it went up on Tuesday. There was a framing crew down the other end of the shopping center that at the end they've been there for 5 days. And they came over and they see this building erected in one day. What you're looking at top left there is only maybe halfway through the day. And they said, "What the hell is this? You're going to put us out of business?" And the contractor said, "We were you last Friday. We just learned how to do this." So it's very simple to learn.
Yeah. That this building is in Oxnard on Rose Avenue if you want to go see it.
The big X's that you see in the corner, that's cross bracing and that's additional shear. Even though Miami-Dade proved every panel is a shear panel, California won't accept it. So we still do the steel strapping cross bracing, which is
Which
fine.
yeah, which you'll see later.
Yeah. This is a slice through. You can see the section through the panel. So the top one is a 4-foot panel. We've cut in where the steel stud slides in. And next to that is a vertical electrical chase on both sides. So what this means is we can cut in an electrical outlet and actually screw the box to the stud in about 1.5 minutes. And now we can have that electrical outlet anywhere on the wall vertically. And that's a big deal nowadays because we've all got plasma TVs, computer screens, and smart homes that need electrical outlets in different locations on walls, which are very difficult to do in a stick-built house.
Yep.
Here you can see where the styrofoam, the panel, is pre-cut and it slots over the bottom track. So this is conventional steel framing bottom track. This is our hurricane tie down and seismic anchor. So if one of those vertical chases is used for electrical, this one's now available for our anchor that ties the roof in tension into the slab. So we can go up to 6 stories doing it this way. Obviously, the stud gets bigger, not just a 2x4. This is what has saved and kept the roof on in all these hurricanes that we've gone through. So the roof is now connected to the slab. The only way the roof's coming off is you've got to pull the whole house and slab out of the ground. It's never going to happen.
And this photograph is a model. So picture the wall being, 10 feet
Right.
high, 8 feet high, whatever size the wall is, it would be a full height wall.
This is tabletop display actually from the showroom, if any of you want to visit.
Yep.
Thanks, Jim. All right, here, this is really important. The stud is centered. So on the left-hand side coating, that's Plastamax. That replaced drywall. Drywall has to touch the stud. So we don't have to touch the stud. So we passed all the fire and impact and everything like this. So you've got Plastamax interior on one side, Stucamax exterior. None of those touch the stud. So we have no thermal bridging. In a wood framed house, you've got thermal bridging every stud, which is 16 on center. Steel framing is 24 on center, which is better, but we have none at all. And this is where that Hurst index I talked about earlier on the 0 to 100, and we came in at 2, is because of this. So we've super insulated every wall. And in addition to that, there's something called an STC rating,
Right.
sound transmission coefficient. Drywall is 26. We're 52. We doubled it. Very, very quiet. So we're picking up kudos for sound and especially insulation.
That's actually really important. And that's one of the biggest feedbacks we get from the houses that we've done when people are living in them is how solid and quiet they feel. They can have their teenager blasting music in a bedroom, you can't hear it. That and the energy efficiency. I want to point out on this photograph, the foam is actually solid filled inside the metal stud. So the foam goes all the way through. It gives you an R30 insulation value for a 6-inch wall. Typical wall is R19, so it's almost double.
This is a project in California this is how they're staged. So the material has just arrived. It's placed next to where we want it. And very quickly, within an hour, probably that corner has been built. Typically, there's 2 people, one on each side. Actually, this is inside the factory, so I get teased all the time about does the contractor have to wear a lab coat? No, you don't. So here's a 9-foot panel. A 9-foot, 4-foot wide panel weighs 9 pounds. A 12-foot panel weighs 12 pounds. So this is our patented double stud connector. All it is 2 2x4s connected. So that's a 4x4 structurally. Nobody builds with 4x4s. So that double stud now holds 2 panels together. And he's going to keep on going. Here's a 90-degree corner, 12x12 corner. Again, there's going to be a double stud holding the 2 together. And then on the 4-foot panel, in between those 2 double studs, is a single steel stud. So it's basically 4x4, 2x4, 4x4, 2x4, all the way through the house. At this point, they're not screwing it together. We're just showing you how quickly you can put the panel together. There you can see right behind the letter, the cross bracing has been pre-cut into it. So that's a shear panel that would also then get the all thread running through it. This is before we started our own steel trusses. Here we're showing cross bracing. So this is a severe case um, engineered for extreme seismic events. I think these were 8 or 9 foot panels. And now instead of the wood open web trusses above it, that's all steel. We don't use wood at all. This is one of the early days projects. This is showing how the electrical outlet gets cut out with a hot wire tool. The box goes in and 2 screws are attached, and that took 1.5 minutes to install that box. So when the panel installers do this, we're shaving a huge amount of time off from an expensive trade, the electrician. So unless it's a union job, which is very rare that we do, the panel installers can actually do that.
Yeah.
Here, the panel installer has cut in with the hot wire tool, the same tool, where the plumbing is going to go. So you've got a vent pipe in the middle, hot and cold, cut into the wall, locked in with a urethane, a non-combustible urethane foam. So at this point, we don't foam the whole thing. We just want to lock it in place, get it inspected. That's the rough plumbing inspection. Then fill the rest of it in. And then we coat over that with our interior Plastamax. This is one of our guys at the factory showing, sorry, it's blurry, how we put Plastamax on a wall, actually Plastamax or Stucco Max exterior, but done the same way. So it's a thin rough coat, about 1/8 of an inch thick, and then we press in a woven mesh, very strong fiberglass mesh. It's actually 11-ounce mesh when industry uses 3.5 and 4.5 ounce. And then it's brought to a beautiful finish by typically a stucco installer. The plasters really have disappeared. And the guys that do good stucco work can easily do really beautiful finishes with our Plastamax.
Yeah, and you can do a smooth steel troweled finish, or you can do a rough stucco finish. We've done everything. It's indistinguishable from any stucco or plaster finish once it's done, except it's completely waterproof and twice as strong. And
Actually, this is around 9,000 psi on the
yeah,
interior,
yeah, and
which means you can't knock a nail in it. So that's the negative. So what we use is a drywall screw that's designed to cut into a steel stud, and you can hang 70 to 75 pounds on just that screw.
yeah,
Kitchen cabinets, find the stud, just like you do now. Things like big plasma TVs, find the stud every 24 inches. This is showing how strong it is. You can see the mesh there. This is a Dodge pickup truck. We actually did a Lincoln Navigator, which was a bit heavier. No cracks, no damage. We're considered an extreme performance coating, abuse resistant. We sell a lot of it to schools and apartment buildings where they know they're going to have tenants that are going to kick holes in the drywall. They're going to break their foot if they try and kick this. You can't even scratch it with a nail. This is in Africa. We shipped a project over. We trained one guy from the Bay Area. He put a team of 7 young guys together. A couple of them are wearing house slippers. They'd never built anything before, and they built this 3,200 square foot house in a matter of weeks. We're now putting factories in Ghana, potentially 3 this year and 3 in Kenya. So it's really taking off in Africa. These are examples of the homes we've already done, whether they're little ADUs or the big, what we call the Beverly Hills house,
yeah,
that we all worked on here.
yeah. These are all houses that we've done with Gigacrete over the years. Did several little houses in Oakland, and then big houses. And we've done everything from big houses to little houses all over California, and also we have one in Hawaii as well.
They're all the same components. There's a joke in the factory when the truck came to pick up the Beverly Hills house, another one showed up with a container to pick up one for Haiti, and I burst out laughing. I said, the product doesn't know if it's going to Beverly Hills or Haiti. Maybe I'm not charging enough for the Beverly Hills guy. He's paying the same price. Anyway, we would love to host you. Any of you that want to come out to Las Vegas, most of California comes there at some point. Check us out. Come visit the factory. We'll walk you through it, and we'll show you physical demonstrations of how we build and how we train contractors.
Thanks,
So
Andrew.
thanks for the
Appreciate it.
time.
Thank you,
Thank you.
Andrew.
So these are two projects that we did fire rebuilds using the Gigacrete system. One was in Ventura from the Thomas fire, and one was in Malibu from the Woolsey fire. Uh, the Woolsey fire was much bigger than the Ventura house, but we'll give you a little.
So in the Woolsey fire, when your house burnt down, it was a traumatic experience. Why did you pick a system for a fireproof house above all?
Well, we knew that it was going to be something that's not it was not an anomaly to have a fire here. It's has a little bit of history with that, and we just fortunately fell into it with got a referral, just random referral, and I wanted to be able to defend my home. I wanted to be able to, really have a chance. Our other home was a stick build, built in the 80s. I spent, I think, $200 a gallon on paint that was supposed to be, fireproof. I had Trex deck, and it all burns really well. So I just love the fact that I don't have to think about that.
We were not even going to rebuild until we heard about the Gigacrete because I didn't want to go through another fire. Every year, every few years, we'd have fires come around. We were always worrying about it. And of course, in 2018, we lost this one. So we decided we weren't going to do anything unless we could do something that would have a chance in a fire. And this has more than a chance, I think. It's a good product.
If you want a different look than stucco, you can still use a fiber cement siding. It can go right over the Gigacrete product, or it can go over conventional wood framing. We've done several projects with this. So it's been around for a long time. Looks like wood, non-combustible. James Hardy Plank is probably the biggest manufacturer of it, but there's several out there, and it works very well. Now they've come out with a lot of different profiles, and you can put this right over Gigacrete. You can put it over conventional framing, and it's pretty much mandatory if you're going to build Fire Smart. They even make a product. One of their profiles is a shingle siding, which a lot of the Palisades houses and were that. This is an indoor test where they tested the party board product against conventional wood product with blown embers, and you can see the results there. This is a house that we did that survived the T fire in Santa Barbara, and that was all done with the fiber cement siding. There's another siding that we've been using for the past 8 years that is an aluminum siding that is a very thick aluminum siding, but it's a powder coated finish. And we use this in conjunction with the Gigacrete siding on the Woolsey rebuild. And it's a very beautiful product, and it's held up really well. We've used it in Maui and oceanfront projects. Held up fine, and it's a fantastic product. So speaking of Class A, so the roofing is one of the biggest factors in fire smart design. Obviously, everything has to be per code, Class A fire roofing, and there's many ways of obtaining that: concrete, clay, slate, barrel tiles, we call them, or Spanish tile. Obviously, these are non-combustible, but they have to be installed correctly. You've seen many houses with this type of roof that still burn. If you look at the slide on the left, the ends are open and the ends on the right of the tiles are filled with mortar. You have to fill them with mortar. You call it a bird stop, but it's really an ember stop. The embers will blow in underneath the tiles on the slide on the left. We also put down a Class A underlayment underneath the tile to because all the tiles, any embers can get up underneath those tiles. So we actually do a roof under the roof.
One of the things I'm doing on a house right now, we're putting Dens glass, which is another fire resistant material over that rolled on material that you see there. If you look again to the right, something Jim said earlier, putting concrete even between the tiles going up the entire roof helps from keeping any embers slipping in under there as well as at the bottom.
A standing seam metal roof, again, a Class A roof is very good. And then even a Class A composition roof is a good choice. I mean, it's a lot of houses survive with this roof. In my case, growing up in the Palisades in 1978, all the houses around us burned. We had just replaced our roof. My parents had just replaced it. It was a wood shake roof. It was very common at the time, and they replaced it with this. And the other houses had the wood shake, and our house survived. One of the biggest weak links in the building envelope that we call it of the exterior of your house is the windows. You need to keep the fire out of the house. High quality dual pane tempered glass windows. The code requires a dual paned window, one pane being tempered glass. We think that's not enough. We we tell people to spend the money on high quality fire rated windows that are designed for fire. This includes a steel frame. You can do a wood frame window as long as it's clad with steel on the outside, but each pane is a fire rated laminated glass pane. And this is crucial. The windows are the weakest link. Yeah, and they can be beautiful. I mean, there are window manufacturers that do traditional steel windows, modern steel windows, but the windows are the biggest element. And this is kind of the tragedy that's happened quite a bit, where uh, stay away from vinyl windows. A lot of people over the past several years have been replacing their old worn out wood windows or old aluminum windows with vinyl. um, Bad idea. The frames melt. Even if you have the dual pane, all of that, and you think they're quality, the frames melt. And we've
Yeah, the Ventura fire, the rebuild that we did, the clients were, I don't know what happened. We just replaced the windows. And we said, well, what kind of windows did you put in? We just put in vinyl windows. And we said, that's the problem there.
yeah, yeah, and
That's the
you
problem.
can see,
Fire came in.
yeah, and the code doesn't even address
You
this.
can actually see where they melted and
Yeah,
folded into the house.
yeah, yeah,
Right.
and the code doesn't even address it. The WUI fire code says you have to have dual paned uh, windows with one pane of a tempered glass. Doesn't even address the frames. Now they're coming out with a new 2025 code, hasn't been adopted yet, new fire code, and we'll see if that addresses it.
Hmm.
The other weak link to most houses is vents. You have attic vents, and if you have a raised foundation, you have crawl space vents. You need to have fireproof vents. Again, the code mandates a 1/8 inch mesh wire, not enough. The embers will blow through that in a heartbeat. We recommend actual vents that are designed to be fire resistant. The best thing is to design a house that doesn't need attics or crawl spaces, doesn't need ventilation. We have a very mild climate, so it's fairly easy to do. But if there are spaces that do need ventilation, we can handle that. Another weak point in the building envelope are rain gutters. We hate rain gutters. We would prefer not to do rain gutters. Unfortunately, they're mandated by LA City, so The Palisades is going to require rain gutters. Malibu, it doesn't. I'm surprised, but LA does mandate them. So if you need to have rain gutters, you need to have gutter guards, and you see commercials all the time for this. Got to keep the debris out of the gutters, but you need to just uh, you need to be careful of the gutter guard that you choose. The one on the left is vinyl. The one on the right is metal. So don't buy the vinyl. It's going to melt. Uh, we can do projects that don't have rain gutters that are very beautiful. Santa Barbara architecture. We have details that we extend the top tile out over it. We flared the plaster up away from the wall. No gutters required. No embers are going to get in. The other thing to consider is everything else around your house besides the house. You have decks, you have pergolas, you have trellises, whatever, barbecue areas. If anything is built, it needs to be built with non-combustible material. So the days of, big wood decks are over, but you can get wonderful materials now that are Class A rated that look just like wood, come in all kinds of different colors, and benefit is also very little to no maintenance. So let's talk about defensible space. Mentioned that word earlier. Everybody's kind of becoming familiar with this. This is basically about landscaping in your site. The idea is to keep the fire as far away from your home as possible. And many jurisdictions, the counties, the cities, have all come up with basically the same thing. They have different zones around your house of different combustible material. You want to have little to no combustible planting or material in zone one around your house. Zone two and zone three gets bigger and bigger. That works well in places where you have houses that are very far apart, like Malibu. Not so much in the Palisades. Palisades is more of an urban environment. Altadena, same thing. Very hard to do this in an urban environment, and we see the results. But they're working on it. They're coming up with a list of planting that's fire resistant, and basically they want you to have from 5 feet all the way around your house, absolutely no planting. This is the result of that, and we saw it first in Coffee Park in Santa Rosa, and then the entire town of Paradise in the mountains, Lahaina, and now the Palisades and Altadena. This is a good example of defensible space. This is more of a Malibu style property where you've got one house with eh, lots of space around it. They've cleared the brush around the house. They have a swimming pool, which we'll talk about. They have tile roofs. That's a classic example of very good defensible space. This is not so much. At first glance, it looks like, okay, the house looks pretty good. Non-combustible roof, minimal eaves. Some of the bigger eaves are fine. They're all protected, small openings, but they've got the vegetation right up next to the house. They got palm trees, which are very flammable, right overhanging the house. Uh, Not much defensible space in the back. The fire's approaching. Probably, I don't know what happened to this house, but it doesn't look good. So additional measures can be taken to harden and protect a home from wildfire. So we call these active measures. Everything so far has been passive measures. Active measures include you can get roll down fire rated shutters that can be automated if the fire's coming. A little bit extreme if you do very good windows like we talked about, probably not necessary. But if it goes with the architecture and you have older windows and maybe you're retrofitting a home to be hardened to fire, it might be a good choice. This is really becoming a thing now, and there are several companies out that are doing exterior fire sprinklers. They have systems that will kick on when the fire comes. You can either do it from your phone remotely, or they will have sensors, and it will kick on and bathe the entire exterior of the house with pressurized water. Problem is, they're controversial, and most cities and counties don't like them. Fire fighters don't like them. What happens is it reduces water pressure, if there is any water pressure. You can imagine if every house had this and it went on, there was no water pressure in anyway in the Palisades, and so this is a problem. So what these companies do now is they will actually um, automate. What you want is a water source that's separate from the city or county water that you want to be self-contained. So we advocate for pools. A pool is an excellent water source. These systems will have a generator and a pump that will either you can have a fire hose if attached to this, or they will automate the system. Interesting little fact: having a pool, the fire department knows every house that has a pool, and they have this equipment on their trucks, and they will make their stands at the houses that have a pool, because they can fight that fire when there's no water pressure in the hydrants. These companies also will have systems where they will have a tank buried in the ground that has a Class A fire uh, retardant foam that they will bathe your house in. So that's another option. And I should say, if you don't have a pool, they will put a tank in the ground if you don't have room for a pool. So those
I think
systems.
even the hot
Yeah,
tubs
yeah,
would,
even a hot tub. Yeah, exactly. Or a big water feature or something. But you want to have your own source of water. So there's a lot of architects out there that are saying, well, it's going to be better. Interior fire sprinklers are required in all new houses. It has been for a little while. Um, so the code requires your new house is going to have interior fire sprinklers. Interior fire sprinklers are not going to do squat for a wildfire. They're just not. And once the fire's in the house, it's all over. Interior fire sprinklers are just to knock down something that happens in the kitchen, or the cat knocks over a candle, or whatever. It is an electrical fire, some little thing, and then you're going to have a bunch of water damage to deal with. But the house may not go up in flames and catch the neighborhood on fire. That's what it's for. A wildfire, there, this is nothing. So if you're going to have the sprinklers, you got to look at the exterior sprinklers. You're going to have these anyway in your rebuild, but they're not going to do anything to cause water damage. Yeah. So the next segment is just a quick segment on working with an architect and a builder.
yeah, so you should select an architect and a builder as soon as possible, because architects and builders will soon become overwhelmed and be booked out for months because of the extent of these fires.
We're talking
So,
about 18,000 houses. Not all going to be built at once, but it's going to be stretched out.
yeah. So having a builder on the team, we like to work that way. And we've worked with Bob for over 30 years. He keeps everything on schedule, on budget. The design phase will allow the contractor to prepare a preliminary estimate as the design progresses in order to stay on the budget and ensure the availability and the timely construction, because builders are going to be really to their eyes with all the construction going on.
What I often do here is, if I get in early and I'm working with Jim and Karen in the early stages, as the project is developing, I will give estimates to the client and to the two of them and see where it's actually going. If an owner does not want to spend the kind of money that this is turning into, work together and try and find ways to back up a little bit, change some of the design, and I will put a very detailed estimate together, and there'll be a sample of it here shortly, um, so that you can see very early in the design stage where it's heading. There's the example right right there. This is only the first page of 3, 4, 5 pages, depending on the size of the project. But I'll put this together even before the plans are completely done, so that you know exactly where the cost is coming in.
Yeah. That way you establish your budget and then the Bob could be doing this during the design phase so that we don't go over budget at the at the beginning phases and find out at the end when we've got everything completed that you're completely over budget.
Yeah, and I think we, on the last webinar that we did, we had a private insurance broker to really, because so many people lost their homes and trying to do budgets with the insurance agencies and whatnot. And so we really work with that and the cost per square foot to keep everything down. So and there's some creative ways to actually get more income and money from these insurance policies that you may not know just by reading it by yourself.
Exactly. And so the idea is you start out with a budget and you want to stay on it. And so don't wait until the plans are finished and then bid the job out to the lowest bidder. There's so many contractors that are coming from all over the country and they're not local and they're quoting prices that are unrealistic and they're taking advantage of the situation. They'll give you low quotes um, even before plans are done, and so you can lock in with them, and they just want the insurance money. Then they can't complete the project, and they walk away. And this actually happened with our client in the Woolsey fire.
The contractor I picked was the wrong contractor. Made the wrong reasons, picked him for the wrong reasons. Picked one that was a reasonably priced rather than one that was really good. And I would say to everyone, pick a well-known contractor. The one I started off with was horrible. He was a contractor from Northern California. Another big mistake, was a local. Northern California, up in Paso Robles.
Let's look at a quick project timeline, uh, just to give you an idea. Now we can speed this up somewhat, but this is a realistic kind of average timeline. The architectural design phase is broken out basically into a pre-design phase, which is research, getting your site survey, soil reports, researching with the city of how big a house you can build, if you want to stay within the like for like plus 10%, that sort of thing. That usually takes about a month. Then we can get into the actual architectural design, and we usually allow about 3 months for that, but it can go fast if you know the client is right on it. You need to make decisions. If you like what we're doing, if you don't like what we're doing, then we'll continue to massage it. We can change design, the style. Work with you until we get it exactly right. And then if you notice the yellow, that's the estimating that Bob is doing during that time. And then we know that we get to the end of the design. We know that we're on budget. We go into the construction documents phase. That's the actual blueprints, we used to call them. Engineering, we get all that done. We can submit for plan check, and at the same time, Bob is finalizing his construction budget during at that time to make sure that we continually stay on budget. The construction documents phase takes about 3 months. Possibly we can go faster than that. Um, the about 60% of the way through, we can submit for plan check because what the city requires versus what we actually do for a construction documents set is less. So they don't require as much detail as we actually put in it to build the house, but we can overlap that. Permitting, they say they're going to turn it around in 30 days. No one has seen it happen yet. There's been very few permits issued, and most of them have been, I think all of them have been projects that were in the plan check phase before the fire. So they are not expediting the way that they say they are going to. Construction then, we've got the permits, can take anywhere from, what, Bob, 12 to 24 months, something like that.
Yeah, depending on the size of the house and the complexity of it.
So for your overall budget, to rebuild. Just as we said, there's a lot of people coming around that are saying unrealistic numbers. These numbers are not related to the fire. They were before the fire for the past several years. Conventional construction now, Gigacrete may be able to beat this by quite a bit. The houses that we've done are significantly cheaper and better based on that. And so, but these numbers are just a budgetary number, just to give you an idea. And so everybody's been saying who's realistic between $700 to $1,000 a square foot. Now we're doing some budgets that are less, that we're trying to be, in the $600 range. This is just based on our experience, and we can potentially do quite a bit better than this, especially with Gigacrete. But it's just an idea, so you get an idea of what we're talking about. So your budget is your hard costs and your soft costs. So your hard costs are based on square foot, and whatever the house is going to be, plus the site work and grading, plus the infrastructure, plus the building, the actual building, which is the cost per square foot, the hardscape and the landscape. So we put all that into a budget, and we have a spreadsheet that we work with that we do that. And then the soft costs are generally 15 to 25% of that. And the soft costs are everything before you break ground. So the survey, which everybody's going to need to get, a soil report, which everybody's going to need to get, the architect, the engineering, structural engineer, civil engineer, et cetera, and the permits. And that typically, those costs it end up being anywhere from 15 to 25% of your overall budget that you tack on. So, what are some potential cost savings? Well, as Karen alluded to earlier, moving forward quickly before architects, engineers, and plan check at the city is just overwhelmed. And the tidal wave is coming. There's already several hundred applications in. Most of them were started before the fire. Um, they're going to get overwhelmed, and we're getting busy. Engineers are getting busy. Builders are going to be hard to come by. The faster you go, the more you will save. Once the hundreds of projects are moving forward at the same time, just substantial delays are going to occur, and costs are just going to rise, supply and demand.
I've already had a number of people who've lost their homes say they know multiple people in their neighborhood, which is very typical. What would be good, cost savings for everyone, is if there were multiple houses that join together and one contractor, one architect can work on a series of them. It cuts down in time. Think of the parking in the driveway. You've got three or four different electricians or plumbers or framers. If you coordinate well and a contractor is doing multiple homes, it'll save money, it'll save time, it'll save aggravation. So that's something to think about.
One thing I wanted to ask you, Andrew, is we're getting a lot of people asking about this, just in terms of the supply and demand situation. And I know the city is talking about finding an area within Pacific Palisades to basically put a pop-up uh, construction material supplier, a lumber yard, that kind of thing. So all of this stuff, but you being based in Nevada, and you get your steel sourced and your foam and all your ingredients from wherever, you're not really going to be impacted by the fire per se, right? I mean, the disaster.
No, no.
Yeah.
I thought where you were headed with this was create some kind of a warehouse situation in that neighborhood, and we ship in all the bulk components. And the
Oh, I
builders
hadn't thought of that. That's an idea.
they can pull from inventory that day, whatever they need that day.
Well, if you get
That
enough
would
projects
definitely
doing
speed things
Gigacrete,
up.
that's an idea.
Yeah.
Yeah.
I also think, Andrew, you mentioned that there's no waste on the building site. So now you're not going to have the construction crews trying to clean up and get rid of all the waste that normal conventional
Yeah, that's a real factor.
construction
Right.
has. You know.
Dumpster costs, Robert would know, they can be hundreds or sometimes thousands a month, and we don't need them at all.
Yeah.
Really, the only waste would you take a trash can, a regular house trash can, and it's the paper bags after we've used the plaster and stucco,
Yeah, yeah, yeah.
and that's it.
I've also already heard a number of things: lumber, steel, drywall going up rapidly in cost. And
Right.
again, to cut it there and imagine all that waste of money for something that's getting more expensive by the day just adds cost to the construction. Whereas Andrew has everything cut to size, brings it out on trucks, and all we do is put it together like a jigsaw puzzle.
Yeah, yeah.
The crews call it Lego.
That's
Yeah.
right.
That's what we call it.
We've always joked and called it the IKEA house,
Even have the plants to put in there.
Yeah.
Of course, not combustible.
Well, thanks everybody for joining us, and we're gonna be doing these webinars continually every couple of weeks, every 2 to 3 weeks. I think the next one coming up, we've got uh, a way of funding some of the soft costs with the Rise Palisades Fund. It's a program that some people are starting to put together in the Palisades to help people fund the soft costs or the underinsured, or if you're even thinking of selling your property, um, to increase the value of your property. And we may also bring in a financial expert who is a mortgage consultant that can help um, with some creative ways of tapping into more money so that we can get everybody back in their homes.
Wanted to thank Andrew Dennis for being our featured speaker tonight. And like I said, we brought construction crews, and we even remember when we brought Bob. Contractors seem, I build the way I build, and I'm not changing. It's amazing after touring the factory how many minds we've changed by the end of the tour that Andrew's given, and the contractors, all of a sudden the light comes on, and it's like very an efficient way of building.
Yeah, and we're happy to meet anybody in Vegas and go through the factory. And also, if anybody wants to tour the Gigacrete homes that we have built in Los Angeles, Malibu, and Ventura, you can go have lunch at Carl's Jr. in Oxnard.
That's an example.
Yeah. So again,
So if
thank you
anybody wants to type in any questions or email us after this, and we can sit and respond to that and really answer everybody's questions, because I'm sure there's quite a few. So
again, thank you to everybody for joining us, and have a great evening. And hopefully we didn't impact your dinner time.
Thanks
Thanks.
for coming.
Thank you.
thank
Bye,
you.
everybody. Bye-bye.
Bye-bye.